Now, this is quite a story from NASA because for the second time in history, a man-made object has left our solar system.
NASA's Voyager 2 spacecraft has been sent back its first message.
When NASA announced that Voyager 2 had suddenly turned back, the news spread across the globe with a sense of urgency and wonder that shook even those who normally paid little attention to space exploration. The spacecraft, launched more than 4 decades ago, had already passed beyond the heliosphere and crossed into interstellar space. For years, it continued its steady journey outward, dutifully sending back data from a realm humanity had never truly touched. Its course was never expected to change, for Voyager 2 was designed to be a relentless traveler, escaping the solar system's grasp forever. Yet the signal that NASA released revealed something no one thought possible. The craft had shifted, turned, and redirected its sensors back toward the region it had left behind. This was not a maneuver programmed by human engineers. Something in the blackness beyond our star system had caused the probe to respond in ways that defied expectation. Before we start, smash the like and subscribe buttons for more updates. The turning back of Voyager 2 was more than a technical anomaly. For scientists, it meant a rupture in the calm assumptions of space exploration. Voyagers were built to be reliable, their instruments straightforward, their trajectories predictable. Yet the data showed a deliberate movement, a realignment of its communication dish and sensing equipment. The first implication struck deeply. Either the craft had encountered a force in interstellar space capable of influencing its behavior, or its instruments had picked up something so profound that its own automated protocols had directed its gaze back toward the heliosphere. Both possibilities pointed toward a revelation of immense significance, and NASA wasted no time in raising the alarm, issuing a red alert. The red alert was not symbolic. It signified the detection of something that could have major implications for planetary safety and the understanding of our cosmic environment. Voyager 2, alone in the dark and battered by cosmic rays, was designed only to observe, not to act. For it to turn back was almost like a whisper from the void, an ancient traveler compelled to deliver a message too critical to ignore. The instruments began transmitting a steady stream of unusual readings, bursts of energy far higher than background radiation, magnetic distortions unlike anything expected in the interstellar medium, and anomalies in the flow of charged particles. These signals indicated that Voyager 2 had come across a structure, or perhaps a boundary, that no human had ever anticipated. For decades, astrophysicists had spoken of the heliopause as the great frontier, the bubble where the solar wind's strength dwindled and the interstellar medium took over. But the data suggested something more layered, more complex, perhaps even alive in a way no one had dared to imagine. When Voyager 2 pivoted, the sensors focused sharply back toward the edge of the heliosphere, as though compelled to examine it again, as though the void itself demanded its attention. The possibility that the probe had detected a massive interstellar current or even a vast energy wave moving toward the solar system instantly triggered fears at mission control. This was no mere trick of instrumentation. The energy signatures were real, coherent, and sustained. Their patterns suggested rhythms, pulses, almost like signals rather than natural static. The scientists parsed the data with feverish intensity, searching for explanations rooted in plasma physics, in cosmic ray behavior, in magnetic turbulence. Yet as the numbers streamed across their screens, the haunting suspicion grew that Voyager 2 was observing something altogether different, something that lay outside the framework of known astrophysics. Across the world, the announcement caught both experts and the public off guard. The thought that a machine launched in 1977, one built with the technology of an earlier age, was now relaying information that hinted at a cosmic structure vast enough to deflect its sensors was staggering. The red alert was NASA's way of saying that the event was unprecedented, that the discoveries carried a significance far greater than just curiosity. There was the implication that Earth and its solar system might be on the verge of encountering forces or entities previously hidden in the darkness beyond the stars. What Voyager 2 found when it turned back was not simply more space dust or erratic cosmic rays. The energy fluctuations displayed coherence, a sense of design. They stretched in patterns that repeated in ways too regular to dismiss. Some scientists began to murmur comparisons to signals, though no one dared to leap to conclusions. Others suggested that what the probe had detected was the footprint of an immense galactic-scale phenomenon, like a shockwave left over from an ancient supernova or a ripple traveling through the magnetic skeleton of the galaxy itself. The awe lay not only in the discovery, but in the realization that such a force could reach across unimaginable distances and still leave its mark on a lone spacecraft drifting billions of miles from home. As the probe's instruments strained to measure the phenomenon, the images they sent, not pictures in the human sense, but complex plots of plasma density, magnetic direction, and particle energy, were decoded into visual representations. These revealed twisting filaments and arcs, resembling colossal tendrils stretching across the void. They bent and curled as though alive, their structures carrying an elegance both terrifying and mesmerizing. To some, in mission control, they resembled a net, an interstellar web that lay beyond the heliosphere, a barrier not of emptiness but of intricate design. If space was once imagined as a silent, empty ocean, Voyager 2 was now showing it to be more like a living sea, rippling with unseen currents and colossal structures woven through the dark. The implications of such a discovery were overwhelming. Humanity had always thought of itself as sheltered within the bubble of the solar system, its sun providing light, heat, and the boundaries of home. Yet Voyager 2 had revealed that beyond that bubble, the environment was anything but passive. Forces were shaping and reshaping the boundary of the solar system, possibly responding to events far across the galaxy. If these forces could deflect Voyager 2's instruments, if they could align magnetic fields in ways powerful enough to cause a spacecraft to reorient, then they were forces worth heeding. Within NASA, voices diverged. Some saw in the discovery a purely natural wonder, a chance to revise and expand the models of cosmic plasma. Others whispered that the coherence, the signal-like rhythms, might indicate intelligence, something that lay behind the patterns. The probe's turning back was the detail that refused to fade. It seemed like a gesture, as if the spacecraft had been nudged, reminded of its duty to observe and report. Machines, after all, do not turn back unless compelled by force or by design. The mystery lay in which of those explanations was true. The world outside the scientific community could not remain indifferent. The announcement spread into headlines, filling homes with talk of Voyager 2 and its astonishing encounter. For many, the news awakened the same thrill that had once accompanied the Apollo landings or the first images of Earth from space. Voyager 2's report was not about human footprints on distant soil, but about the universe revealing itself in ways that unsettled and inspired. People gazed at the night sky with fresh eyes, wondering what structures, what hidden boundaries lay beyond the stars visible to them. What struck most deeply was the timing. After decades of silence, when Voyager 2's signals had become a steady background to other missions, it was now at the edge of human awareness again, carrying a message that demanded attention. Its discoveries were not just scientific curiosities. They hinted at a universe more dynamic, more alive, and perhaps more perilous than anyone had realized. The red alert issued by NASA signaled that humanity needed to prepare, not necessarily for disaster, but for a transformation in understanding. The cosmos was not just a void to traverse. It was a realm of immense forces, and perhaps even unseen presences, and Voyager 2 had brushed against their edge. The detail of what Voyager 2 uncovered stopped the world because it suggested that the boundary of the solar system was not the end but the beginning of something vast. The tendrils of energy, the pulsing patterns, the reorientation of the spacecraft all pointed toward an interaction at scales too great to ignore. Humanity's first true step into interstellar space had unveiled not emptiness, but structure, not silence, but rhythm. That discovery alone was enough to alter the trajectory of scientific thought for generations. In every culture, the stars had been seen as symbols of destiny, eternity, and the unknown. Voyager 2, with its golden record carrying greetings from Earth, had long been viewed as an emissary of humanity to the cosmos. Now it seemed the cosmos had answered not with words, but with a demonstration of power, a display of forces beyond imagination. The red alert was not just NASA's call to scientists, it was a wake-up call to humanity itself, a reminder that the universe is not passive, that the boundary between home and the beyond is alive with mysteries yet to be understood. As Voyager 2 continued to transmit, Its journey turned into more than a mission of exploration. It became the voice of the cosmos, relaying truths humanity had not asked for, but desperately needed to hear. The world was stopped not by fear alone, but by wonder. The kind of wonder that redefines existence and reshapes the way a civilization sees itself in the grand tapestry of the stars. Voyager 2's sudden shift, its inexplicable turn back toward the heliosphere, was the kind of revelation that unfolded in layers. At first, it was simply a spacecraft realigning its sensors, but the longer the stream of data continued, the clearer it became that this was no accident and no mechanical quirk. The instruments were tuned into something, registering forces and fields that had never before been cataloged. As more transmissions arrived, the scientific community realized this was not an isolated reading but a continuous phenomenon that Voyager 2 had locked onto, as if the spacecraft had stumbled across an ocean current in the vastness of interstellar space. The raw telemetry painted a portrait of a universe far more active than expected. Magnetic distortions were recorded not as random fluctuations but as braided patterns stretching across immense distances, their scale impossible to truly grasp. The probe's instruments showed changes in particle velocity, subtle but consistent, suggesting streams of energy moving with intent, almost like rivers through the galactic void. This was not the emptiness humanity had envisioned when imagining the space beyond the sun's reach. Instead, Voyager 2 was revealing a dynamic frontier, an interstellar weather system of staggering proportions. For decades, astrophysicists had speculated about the structure of the interstellar medium. They knew it contained dust, plasma, and radiation. They modeled its turbulence, imagined its density variations, and debated whether it shaped or bent the edges of stellar systems. Yet no model had predicted what Voyager 2 now transmitted: coherence, rhythm, and structure. These findings raised immediate questions. Was the solar system surrounded by vast filaments of magnetic energy that formed a kind of cosmic shield? Were these tendrils the remnants of ancient stellar explosions, woven into space like scars? Or was something else guiding their shape, some principle that humanity had not yet discovered? The intensity of the signals suggested power on a scale almost incomprehensible. Even millions of miles from the boundary, Voyager 2 was registering disturbances strong enough to alter its trajectory of observation. This raised the unsettling possibility that the solar system itself was enveloped in a vast external influence, one that stretched beyond the galaxy's ordinary turbulence. If such a force existed, it meant that humanity had been living within its embrace all along, unaware of its presence until Voyager's instruments revealed its edge. What truly stopped the world, though, was not only the scientific mystery, but the human realization of proximity. This was not a distant star or galaxy being studied through telescopes. This was a phenomenon pressing directly against the frontier of the solar system, at a boundary humanity's machines had only just crossed. It was immediate, palpable in its implications. Earth was no longer an isolated island orbiting a star. It was part of a larger dynamic system whose hidden elements were now stirring into view. The cultural impact was profound. News reports around the world captured the public imagination, showing visualizations of the data that transformed the abstract readings into images of glowing filaments weaving through the dark. Artists depicted them as cosmic rivers or living currents. Religious leaders interpreted them as signs of deeper design, while philosophers debated whether humanity had underestimated the complexity of reality itself. The sense of wonder was universal. For the first time in decades, space exploration had not just fascinated but unsettled people, igniting conversations at dinner tables, universities, and governments alike. At NASA, the mission control teams became the guardians of a discovery so strange it defied easy categorization. Their role was no longer simply to monitor an old spacecraft, but to interpret a message from the edge of human reach. Voyager 2 was not just sending data, it was transmitting a glimpse into a dimension of the cosmos that had been invisible until now. Scientists who had spent their careers studying plasma waves and cosmic rays found themselves staring at readings that did not conform to any known pattern. Some compared it to hearing a song faintly through static, structured, repeating, but unlike anything produced by nature as they understood it. The longer Voyager 2 observed, the clearer the patterns became. These were not single pulses but layers, overlapping frequencies that rose and fell like harmonies. The probe's plasma wave instrument detected oscillations that echoed across hours, then repeated days later, suggesting a system not of randomness but of order. The implication was staggering. The boundary of the solar system was not passive. It was active, responsive, and perhaps connected to something far beyond. This discovery shifted scientific priorities overnight. Research teams that had long awaited scraps of data from Voyager now worked in urgent rotations, analyzing the transmissions in real time. Papers were drafted, models rewritten, theories overturned. Some proposed that what Voyager 2 had found was a galactic-scale wavefront, the remnant of stellar cataclysms traveling through interstellar space like ripples in a pond. Others speculated about dark matter interactions, pointing to the possibility that the probe was detecting forces tied to the unseen scaffolding of the universe. But the most provocative voices suggested something more: the potential for artificiality, the idea that the patterns resembled signals not only coherent but communicative. Though officials avoided such language in their public announcements, the thought lingered in every discussion. Could this be the first undeniable evidence that intelligence existed beyond Earth? The rhythms and harmonies of the plasma waves were unlike any natural turbulence previously recorded. They seemed designed, or at least guided. If so, then Voyager 2 had done more than detect interstellar weather. It had brushed against the work of an unseen hand. As the transmissions continued, humanity was forced to confront a truth it had long suspected but never proven. The universe was far more intricate, far more alive with processes and perhaps presences than anyone had dared to accept. The red alert was not a gesture of fear, but of necessity. NASA needed every observatory, every theoretical mind, and every technological tool focused on this revelation. The possibility that the solar system itself was part of a larger cosmic network meant that Earth's place in the galaxy was not isolated, but interconnected. Governments took notice. The possibility of forces beyond human control brushing against the solar system carried implications for security, for planning, for the very concept of human survival. What if these waves or filaments could disrupt satellites or interfere with space travel? What if their power extended inward toward planets? Though there was no evidence yet of danger, the mere possibility demanded vigilance. Humanity had spent decades assuming that the greatest threats came from within the solar system: asteroids, solar flares, planetary instability. Now Voyager 2 was suggesting that greater powers lay just beyond, shaping the environment in ways unknown. The cultural imagination leapt ahead of the science, as it often does. Books, films, and artworks seized on the imagery of Voyager's discovery, depicting colossal webs of light surrounding the solar system, or vast cosmic rivers pulsing with energy. These depictions were not simply artistic license. They reflected the genuine awe of a civilization realizing it lived in a far richer cosmos than imagined. The spacecraft, once a symbol of human engineering and exploration, had become something more: an emissary, a bridge between humanity and the unknown. What Voyager 2 uncovered also raised profound questions about the nature of exploration itself. For centuries, humans had viewed exploration as expansion into emptiness, sailing oceans, crossing continents, launching rockets into the void. But if space was not empty, if it was filled with vast structures, rhythms, and possibly even signals, then exploration was not about venturing into silence, but about encountering forces already present. Humanity was not the first to leave its mark on the interstellar medium. It was arriving in a place already shaped by phenomena beyond comprehension. The discovery also reshaped the very idea of time. The structures Voyager observed were ancient, their scale suggesting processes that had unfolded over millions of years. To detect them was to peer into a history written in plasma and magnetism, a story of stars dying, waves propagating, fields bending. Every pattern Voyager recorded was like a fossil, evidence of cosmic events that predated humanity by epochs. The spacecraft had become a historian, documenting the ancient dynamics of the galaxy, reminding humans of their youth in a universe of unimaginable age. Yet the turning back of the spacecraft remained the most haunting element of all. Machines do not turn without cause. Something in that frontier had compelled it, and that act carried symbolism too powerful to ignore. It was as though the probe itself recognized that the discovery was too significant to pass by. It reoriented, fixed its gaze, and began to transmit with purpose, almost like a messenger turning back to speak. Whether it was an automated response to data thresholds or the influence of external forces, the impression it left was unmistakable. The cosmos had called, and Voyager had answered. The red alert marked a moment when humanity's perception of its place in the universe shifted permanently. The discovery was not just about plasma or magnetism, not just about patterns in data. It was about meaning, about recognizing that the universe is more complex, more filled with mystery than anyone had dared imagine. The stopped world was not paralyzed by fear, but by wonder, by the realization that the first step into interstellar space had revealed not emptiness, but connection. Voyager 2's transmissions continue, fragile and faint across the light years. Each bit of data is a thread tying humanity to the vastness beyond, a reminder that the edge of the solar system is not an end, but a threshold. The spacecraft, battered but enduring, has become the voice of that threshold, speaking truths that reshape everything from astrophysics to philosophy. Its turning back was not a retreat, but an invitation, a call to look again at the universe and see it not as void, but as living, dynamic, and filled with mysteries yet to be understood. And as the signals arrive, humanity listens, awed, unsettled, forever changed by the revelation that the universe has more to say than silence. The cascade of revelations from Voyager 2's unexpected turn created a tidal wave of intellectual and cultural response that rippled across every domain of human thought. Each dataset that arrived was no longer simply the sterile output of a distant probe, but a mirror, forcing humanity to confront its assumptions about space, existence, and the boundaries of knowledge. The very language of science, art, and philosophy strained under the weight of what the spacecraft was transmitting. The scientific community found itself facing questions that blurred the edges of multiple disciplines. Plasma physicists argued that the ordered structures Voyager detected might be evidence of self-organizing systems within interstellar space, akin to the way patterns form in fluids or biological networks. The coherence of these readings hinted that energy and matter at cosmic scales might behave in ways parallel to life itself. This notion drew biologists into the conversation, as they considered whether such structures could exhibit qualities of living systems without resembling anything terrestrial. Was Voyager not merely observing a galactic current, but perhaps the skeleton of an emergent, vast-scale organism? Meanwhile, astronomers debated the consequences for galactic dynamics. If filaments of energy were weaving through interstellar space, perhaps the galaxy was interconnected in ways previously unseen, a web of plasma rivers that linked stars and planetary systems like a hidden nervous system. Such a discovery implied that solar systems were not isolated units but nodes in a galactic network, constantly bathed in information and energy flows. The possibility that Earth's star was connected to this network unsettled long-held assumptions of cosmic isolation. Humanity, it seemed, was never truly alone, not because of alien civilizations, but because of the fabric of the universe itself. Theological interpretations emerged with surprising intensity. Across traditions, leaders grappled with what it meant that the boundary of the solar system revealed order and rhythm. Some saw in the Voyager data a manifestation of divine architecture, a signature of creation woven into the very plasma of the galaxy. Others viewed it as a reminder that the sacred was not confined to Earth or its immediate heavens, but extended into the unimaginable depths of interstellar space. Ancient scriptures that spoke of waters above the firmament or pillars of the cosmos were reinterpreted as metaphors for the structures Voyager had uncovered. Congregations worldwide were stirred not by fear, but by awe, finding renewed relevance in texts long thought symbolic. For philosophers, the revelation forced a reevaluation of the very concept of boundaries. The heliosphere had been considered a frontier, a line marking the end of the sun's influence. Yet Voyager 2 showed that this frontier was porous, dynamic, shaped by interactions that extended far beyond the sun's reach. Boundaries, then, were not fixed but alive, places of transformation rather than separation. This realization spilled into other disciplines, inspiring thinkers to reconsider how human societies defined borders, how consciousness perceived thresholds, and how reality itself might be structured as a continuum rather than a series of isolated domains. Cultural responses unfolded with an immediacy that reflected humanity's hunger for meaning, Artists painted vast canvases of glowing threads stretching into infinity, sculptors built installations mimicking the twisting filaments of plasma, and musicians composed symphonies inspired by the oscillating rhythms detected by the probe. Popular culture absorbed the imagery swiftly. Films and novels began portraying the cosmos not as a cold vacuum but as an ocean of living energy. Children gazed at these depictions and grew up believing not in the void but in a universe rich with hidden architecture, reshaping how a generation would approach science and imagination. The geopolitical implications, though quieter, were no less significant. Voyager 2's discovery emphasized the fragility of human knowledge and the need for shared vigilance. Nations realized that no single country owned the cosmos, that discoveries at the edge of the solar system belonged to humanity as a whole. This recognition spurred renewed cooperation, at least temporarily, in international space efforts. The data from Voyager became a shared treasure, transcending national rivalries. At the same time, some governments saw strategic opportunity, wondering whether understanding these interstellar forces could lead to new technologies, new forms of energy, or even new defense strategies. The dual nature of discovery, its potential for unity and division, played out in diplomatic halls as leaders wrestled with what it meant to live within a solar system influenced by external forces. Education transformed rapidly under the weight of this discovery. Textbooks were rewritten, no longer portraying space as a simple gradient from planetary orbits to emptiness, but as a layered environment with boundaries rich in phenomena. Students were taught that the solar system was part of a dynamic galactic sea, its edges rippling with currents and fields. Classrooms around the world buzzed with excitement as children realized they were growing up in a time when humanity had taken its first steps into interstellar space. Teachers no longer struggled to make science relevant. Voyager's revelations had made the cosmos immediate, a presence pressing against the edges of the world. In literature, the metaphors of Voyager 2's turn seeped into every genre. Poets wrote of the spacecraft as a sentinel turning back to warn humanity, as a wanderer pausing to share secrets from the unknown. Novelists constructed stories in which cosmic filaments were characters, ancient intelligences woven into the structure of the galaxy. Even political writers invoked Voyager's discovery as a metaphor for human society, its borders porous, its forces interconnected, its rhythms larger than any one nation could control. The spacecraft had become not just a scientific instrument, but a symbol, reshaping the language of human self-understanding. The psychological impact of the red alert was profound. For decades, people had grown accustomed to thinking of space as distant, abstract, and irrelevant to daily life. Suddenly, the boundary of the solar system had come alive, its unseen forces brushing against humanity's awareness. This realization triggered both exhilaration and unease. Exhilaration, because it confirmed humanity's suspicion that the universe was filled with wonders. Unease, because it suggested that forces beyond comprehension could influence Earth without warning. The sense of control, so central to modern life, was shaken. Humanity was reminded that it lived not in isolation but within a system shaped by cosmic powers. Among scientists, the concept of communication lingered persistently. Though no one could definitively call the plasma rhythms a message, the resemblance was striking. Oscillations repeated, harmonics layered, patterns echoed across intervals. Whether natural or intentional, the data forced the question: what if the universe itself carried information in its very structure? What if Voyager had not discovered life as humans knew it, but a form of cosmic communication written into the plasma and magnetism of interstellar space? This possibility opened a new field of speculation: cosmic semiotics, the study of whether the universe's large-scale structures could themselves be interpreted as language. The practical consequences for exploration were immediate. Missions once designed to orbit planets or map asteroids now had to contend with the reality of interstellar environments. Space agencies began planning future probes with more sensitive instruments for plasma waves and magnetic fields, recognizing that the frontier was not simply physical distance, but an ocean of phenomena yet to be charted. Engineers revisited designs, imagining spacecraft not as lonely travelers through emptiness, but as vessels navigating currents, much like ancient sailors first learning the patterns of winds and tides. The metaphor of navigation returned to space science, reshaping how humanity envisioned its journey outward. Relativity itself came under scrutiny. If Voyager had detected forces coherent across vast distances, what did that mean for the speed of information in the cosmos? Could plasma structures transmit changes faster than light across their filaments? Could they act as conduits, linking regions of the galaxy in ways Einstein had not imagined? The discovery revived debates about the very laws of physics, as researchers explored whether the cosmos contained hidden shortcuts or frameworks that defied conventional models. Voyager had not just broadened knowledge, it had destabilized the foundations of certainty. Yet the emotional core of the discovery remained the turning back. Humanity could not escape the symbolism of that act. In every culture, turning back carried meaning. Returning to warn, to share, to acknowledge something left behind. That a machine built by human hands had enacted such a gesture made the event uncanny, resonant with myth. It was as if the spacecraft had stepped across the boundary of the known world, glimpsed the beyond, and then turned to say, "Look closer, there is more here than you realized." If you liked this video, please give it a like and subscribe to our channel. Also, leave your comments below and tell us. What are your thoughts on Voyager 2's return? Will NASA's red alert reveal danger? We want to hear from you. Thank you for watching, and see you next time.